Okay, so for this particular problem, they have told you that your parent function is the graph of f of x equals 2x squared, and then they've given you a graph that's been translated, and they want you to write the equation of what the translated graph is. So remember, your vertex form is a equals x minus h squared plus k. They've already given you the a because they gave you that 2 in the problem. So that means you have a vertical stretch. They told you that, which was actually kind of nice of them. They usually don't tell you that. And so they want you to use the picture to find the other pieces of information that you need to know, which is the h and the k. All right, so in order to find the h, you need to find out how far right or left it was translated. So remember, if it was translated to the right, they're going to use a minus sign. But if it was translated to the left, they're going to use a plus sign, okay? So normally your vertex would have been located at 0, 0, but it looks like they went right 1 unit. So because they went right, we're going to put a minus 1 for the unit they went right. And then the k value comes from if they moved the graph up or down. And if they move it up, they're going to use a plus. If they move it down, they're going to use a minus. So in this problem, normally you'd be at 0, 0, but they moved you down. And it looks like they moved you down 3 spaces. So on the outside, you'd put minus 3. And that is your solution for that first one. Okay, so for this one, it says the function f of x equals negative 0.25, which is negative 1/4, x minus 2 squared plus 8. Models the path of a volleyball when the player is 2 feet from the net. The height of the net is 7 feet 4 inches. Will the ball go over the net? What if the player moves back so she is 4 feet from the net? Okay, so there's 2 different questions that we need to know. If you want, you can graph the graph if you'd like to. It's really up to you. Probably not a bad idea to go ahead and graph it. We know where our vertex is going to be because our vertex is going to be right 2 spaces and up 8 spaces. Okay, so our vertex is right there. And then if you wanted to get some more points, you could plug in some values if you wanted to. Okay, so we know our vertex is at 2, 8. So we could plug in like 3 and 4. We could plug in 1 and 0. So remember, 0 and 4 should give us the same value. Okay, so let's plug in the 0 and see what happens. So if we did plugged in the 0 and we did the right order of operations, if we took 0 and took away 2, you would get negative 2. And if you squared the negative 2, you would get a positive 4. And if you did a negative 1/4 times 4, you'd get negative 1. And negative 1 minus 8 would, negative 1 plus 8 would give you 7. So we'd be at 0, 7. Which would be here and here. Okay, so here's our graph of the parabola. Okay, so it says they've located the volleyball net at 0, and it says that the volleyball net is 7 feet 4 inches tall. So we know this is 7 feet right here. So the volleyball net's higher than that. Okay, so this is the net. And so the question is, will the ball go over the net if the player is 2 feet from, the net? And the answer is no. Because look, it's going to hit. So then it says, so it's not higher than the net. You're going to run into the net. And it says, will the ball go over the net if the player is 4 feet from the net? Now, this is what the graph looks like when the player is standing 2 feet from the net right here. The trajectory of the ball doesn't change, just the location of where the ball is hit changes. So if the player were to take 2 steps back, they'd now be located over here at 4, negative 4. And so what that's going to do is it's going to pick your graph up, and it's going to move the trajectory of the ball back 2 spaces. And I'm just doing a really rough sketch. But remember, the net's right here. So would the ball pass the net now? If the player steps back? It sure would. And if you're struggling to see, like, how the heck did they get that equation? I don't know where it's coming from. Okay, well, you already know the A value because they gave you the A value in the problem. So the A would be the negative 0.25 or 1/4, however you want to write it. The H value is how far to the right or the left it was shifted off the y-axis. Well, the vertex is on the y-axis, so it wasn't shifted right or left at all. And then the K value is how far up or down it was shifted off the x-axis, and it was shifted 1, 2, 3, 4, 5, 6, 7, 8 spaces up. So if the player stepped back, the path of the ball would be this, and it would clear the net. Okay, the last problem, they gave you a graph, and they want you to write the equation in vertex form. Okay, so first thing I would do is pick out my H and my K value. So remember, your H value is how far right or left it was shifted, and your K value is how far up or down it was shifted. And we're looking at the vertex when we do this, okay? So that's going to be that dot at the bottom. So when you compare it to 0, 0, it looks like they went to the right 1 space, and it looks like they went up 6 spaces. So remember, right and left, it happens inside the graph. And if you're moving to the right, you do a subtraction sign. Up and down happens outside of the function, and they went up, so that's +6. The other thing you'd want to look for is if there was any stretching or shrinking. So remember, in a normal parent, which is just your typical y equals x squared, you have a dot at 0, 0, and then your next dots are at 1, 1, negative 1, 1. So look and see if they have that same pattern up here. Is it over 1, up 1? And if it is, then there is no stretch or shrink, which means your A value is equal to 1. So in math, because we're lazy and we don't like to write, we just eliminate that 1. If you wanted to, you could technically put the 1 there. Most people will not do that.